all teams are requested to have to be working on MBAL and to make some outputs depending on the data we will provide you with. So it's expected that you will work in the software, and we will also check with you if you don't have the software. So we may be able to provide some kind of help. Okay, so excuse me just a minute because I'm trying to open the software in another device. That's just a moment, please. Okay, good. So just a moment, please. Okay. Okay. So can you see my screen as the software of MBAL? Can you see
Yes.
can you see it well?
Yes, we can see it.
Oh, okay. That's okay. So I'll try to go through the software quickly, and I have some not say theoretical data, but it's about QC and the main section of the MBAL. But before going into presentation, let's have like a quick view of what we shall do with MBAL, and we will go through the presentation to see what is the advantages and what is the data required, QC and so on. So I believe that most of you may be familiar with the MBAL. Some of you may not still undergrad or even grad, but may not don't have the chance to work on the MBAL itself. So simply in the MBAL, normally we refer to MBAL as material balance. However, as you can see, we have some other tools like reservoir allocation, Monte Carlo, decline curve analysis, 1D modeling, multilayer, and so on. But normally, we are familiar with the material balance, and we refer to MBAL as a material balance. So I will go through. Of course, I will go back. I will go to the presentation, and I will, if there's some time, we can go back to the software specifically for to show you some cases and some comparisons between different cases so that you can test the advantage of the MPAL. Okay. So simply, the MPAL material balance, we called it like a zero dimension. In reservoir engineering, you know that we have different types of modeling, and on top of them, and the top of them is the reservoir modeling using any kind of software like Petrelity, Navigator, CMG. All are dealing with different parameters and accounting for direction and so on. But here in MBAL, you can consider it like a zero dimension. We cannot account for any direction. We cannot account for any locations and so on. It's just like mathematical equations supported by physical behind to solve some problems or to give you some quick insights about your reservoir. Then you will go for sure and make more integration and so on. So simply, if you're gonna work on the MBAL, you can see something like this. We call it tank model for MBAL. I'm sorry. Okay. So as you can see, we one of the best advantages of the IBM package, IBM stands for Prosper, MBAL, Gap, and so on, is that they are smoothly working, has a smooth working workflow, so that you can start with from left to right. You will go from left options, BVT, input history matching, production prediction, and so on. So this is some kind of smooth operation. So, for example, let's say the first of all that you will have a file, make a new project, and you will have this screen layout. Okay, you can get a file and make a new project, or if you have already existing project, you can go to and open this project. Okay, and after that you will have this layout. This layout you will have like this tank. So you're gonna start from left, as I mentioned. Options, it's something like you just give some information about your model, like which type of fluid is it you are working in, oil or gas condensate or something like this. In this case, for simplification, we are working in oil, and you can we have just one tank. Tank means a reservoir. So you are dealing with just one reservoir or different reservoirs. For sure, it depends on your understanding. If you are working in area, let's say with one reservoir naming, let's say Balaim Reservoir. But from your understanding, you know that Balaim can be divided to high quality Balaim and low quality Balaim. So that at this case, you're gonna use multi tank, because you know that each tank. What do you mean by tank or reservoir? We mean we are simply talking about performance. So if this reservoir had a different performance from this reservoir, so now we have multi tank or different reservoirs or multi reservoirs. Okay, and even for the BPT, is it variable BPT and simple BPT? Normally we go with simple BPT. And here is something regarding the production data. We will go through it. We're gonna enter the production by tank. Let's say that you have a reservoir and we have 100 wells in the reservoir. So it will be a nightmare to enter the production data by well. So you can just using any other supporting software like OFM, any production software like OFM. You can combine easily all of your reservoir wells by categories. So you can say I need the production of Balaim reservoir. So he will give you the production of Balaim reservoir, and you can come directly and insert it in the MBAL. So it's by normally also it's by tank. And we don't have computational, some information about the company location. This is something for your reference, because at the future you may return back to what we have did to check some things or something like this. So it's something for your reference, and I personally prefer this open area to define what is initially the objective of having this MBAL, because MBAL MBAL has many objectives, as we will see now. So for example, here the objective is to make a QC in the reported storage, the oil in place. I got mainly the rule, or the one who report the oil in place is not the engineer, it is the geologist. So you have the geologist told you that we have here a storage of X number, let's say 50 million barrels of oil. Okay, so and we have your production data. So one of the objectives of the software or the MBAL is to make a QC on this storage. Is it correct? Is the MBAL see a less volume? So you have three cases. You will see an exact nearly volume according and matched with the geologist, or you can see higher volume. And in this case, we need to check with the geologist and check we need to think where this volume of oil is coming from, because it may be for sure a potential for drilling new wells and so on. And this is what actually any company or managerial or top management are seeking. And the other side, or the other case, which is not favorable, is you can see less volume than the geologist. And in this case, it means that your reservoir is not continuous, is not homogeneous, and it's not of the good news. Okay, so that's why I prefer this area to write down what's in your mind, the objective. If you have any kind of uncertainty in data, if whatever it's in your mind, just your time plan for completing this task and so on. Okay, so okay, are you coping with me? Do you hear me well so far right now? Oh, I can see the chat. Yes. Okay, that's great. That's great. Okay. Okay, that's great. Very good. Very good. Okay, so the other section, which is one of the main important one, is the PPT. Okay, so after putting what's in your mind in the option section and defining your initial model, so directly you will go to first of all is the PPT. Okay, so as you can see here, it's here worth to mention that in the internship we will try to, and this is one of the objectives of the asset team, in addition to socializing and formalization and diversity and so on. One of the main objectives is that to mimic what we are working in what we are doing in our daily routine and daily work. So I'm not work on my own. I'm not working alone. So I'm a reservoir engineer. I'm working side by side to the geologist, to the petrophysicist, to the geophysicist, which is under the umbrella of GNG and petrology and biology. And I'm working with the field engineers. I'm working with the drilling engineers. I'm working with the production technology engineers. So we are, as uh, as I mentioned, we are more than 7 to 8 disciplines. So and another thing is that we are all depending on each other. So as you will see here, here you need the PPT. So there's a man responsible for the PPT from the reservoir engineering team. And in your internship, you will see this. You will have like, that's why we have three reservoir engineers. So one will be for MBAL, one will be for the PPT, and so on. So the guy who is gonna work on MBAL will need the help from the PPT guy. So he will be waiting for him to make sure that the PPT is valid, is to make the all required QC and so on. So after that, the PPT guys shall give you like a report, a normal report of PPT, having a GOR, gravity, salinity, and so on. And you're gonna make something like matching. If you have a complete table, it will be a piece of cake. It will be nice. If you don't have, you may have just one row or something like this. So you will go and make matching by like something like this. You will go and make matching by correlations and so on. Okay. So after that, it's done. Now we have, as you can see, again. Now he will take he will make like this ticking that your data is already matching. So now it's okay for you. So done. And so the third tab is your input. You're gonna make your input data. So again, here you will be depending on the petrophysicist guy in your team. You have, I think, one or two guys to work on the formation evaluation, so that he will give you the porosity. So your porosity, you shall take it from him. Also the connect water saturation, and so on. And as I mentioned earlier, that the oil in place, you can take it from the geologist, or you can estimate it if you don't have any figure about it. So if it is from the geologist, so okay, get it, and we will work on the MBAL and see the result and compare. If it's not about the geologist and you know how you know figure out about it, So this is the RE, depending on the understanding, he can estimate any number, and later on he will adjust it. Okay, and this, yeah, the temperature also from the PVD. And here is a trick. I will not talk about it right now. We will let it empty for you, and you will test how you gonna estimate your initial pressure, or what's in your mind to get the initial pressure from data set you have, and you will be working on it. Okay, so here simply you're gonna input the tank parameters, simply pressure, temperature, porosity, and so on. And here I will go some 2 or 3 slides about the water influx, because it has some debate to discuss. But the simplest way, or initially, we can consume normally that it's like the ideal life. It's like radial aquifer. In actual data, it's not normally it's not radial, but we will assume it's radial aquifer, and you will give some assumption to the aquifer parameters like the thickness, the radius, and the angle, the permeability, and so on. Okay. So this is the second. Direct compressibility. Normally we go to use it from correlation, unless you have a core, and some special core tests are performed to determine some of the geomechanics. It's something related to the geomechanics, and normally because this kind of tests are very expensive. So I want to say that you will not find this kind of data in your company, maybe just one well or something like this, and maybe not representing what's actually we see in the operation. So normally we go with the porosity, and we say that from correlation. Um, Here, normally, if you have like a loose sand, this is a different case, but we will not work on this case. Normally, we will go with consolidated sandstone, no problems of sand control and so on. So this we will let it empty. Okay, then the relative permeability. This is what is the importance of the relative permeability, is that when you're gonna make a prediction in the history matching and the validation of our model, there is no need for the relative permeability. But if you're gonna make a prediction and what will be the performance, of course, for example, if you're gonna make injection, let's imagine that you don't have water injection, and after some years or after some time, we will have like water injection, and you want to make what is the predicted oil or the predicted fluid, predicted water cut. You cannot make a prediction unless you have the behavior of the oil. Relative permeability in simple ways means that how oil will move, how water will move, okay, in comparison to each other and relative to each other. It's like, yeah, there are two cars with different types on the same way. So how will each car will move relative to the other, depending on other surrounding factors and so on, something like this. So let's say that we have low water saturation, and another case we have high water saturation. So what will be the impact on the moving of oil and the moving of water? This is the relative permeability. So that's why we need it to have an estimation and the prediction of our future performance. And finally, the most important one, which is your production pressure performance. This is one of the most important steps, and for sure we will give you a template or something of kind of data to import into your MBAL and begin to make analysis. Okay, so I'm going quickly through the software, because my objective is to give you the both things, some theoretical assumption to have an understanding, and some familiarization with the software. And let's say that it's not about this type of training or internships that give you all the steps and all ways, and you just are mimicking me, or just are duplicating what I'm doing. No, it's about giving you the theory behind, the main items to look to take care of, and the normal workflow, and then we will start. And you make it in your own, and you have mentors with the groups who can come and ask them, but ask them for critical points, not to let them make you the steps. Okay. So this is one of the most important tabs, which is the input data. Again, you will give just an info about your reservoir, and you get it from different disciplines. make an estimation about your influx, the aquifer. Here, the water influx, we mean the aquifer. So if it is a strong aquifer or weak aquifer, again, it depends on your experience and understanding of the reservoir. That, for example, you can see wells are producing water and the pressure does not deplete, the pressure is constant. So for sure, we have a strong aquifer. Vice versa, if you don't have a pressure sustained, pressure is declining, so you have a moderate to weak aquifer. So depending on the water producing, so you may have some amount or significant water producing, so it may be a moderate aquifer, or you don't have water at all. So it seems like this is like a small pot, or as you can see, none. There is no aquifer. This is theoretically. Normally, there is water below the oil. But let's say that maybe a small pot, something like this. We call it a small pot, and just you make it like an estimation of the volume or the water aquifer you have. Okay. Oh, okay. So, and again, rock compressibility depending on porosity, relative permeability is important in prediction scenarios, and the production history, production pressure. Take care its production, its date, pressure, and all of your cumulative oils. This is the main driver for the MBAL to start working on. Okay. Now you are ready. You have now, let's say you collect the data, you make some kind of QC for sure, and you imported your data, make some analysis, and your PVT, your IMP, and so on. So now it's ready to go. You still didn't make an MBAL model, but it's ready to go. So the following direct second step is to begin your history matching. Okay, and here we have normally two ways. We call it analytical method and a graphical method. Normally, we pay focus to the analytical method. So, for example, something like this. As you can see, what I mean by history matching or analytical method, as you can see, uh, these are these are your MBAL. This is the red line. These are your MBAL. And what you can see, these points are the actual data you previously imported in the input. Okay, this is like the tank pressure versus the cumulative production oil. So you can have like a good match. Okay, it is something we call it like art of science. It's like something between art and science. Science. Uh, it's understanding. You can see that, oh, I can see these real data show much depletion. The pressure is actually depleted than the MBAL. Okay, so it means that the MBAL has some energy which is not in the actual real life. You got it? Again, you got it? So simply as a quick view, we call it quick view. I can see the data and see that this pressure is depleted actually. But the MBAL, yes, it's depleted, but not as much steep as the real data. So it's this difference, this difference, this is energy. It is corresponding to energy. And it means that the energy in the MBAL, which I make, is more than the actual energy. Got it? I think now you got it. So what you want to do, this is the understanding or the science. I began to interpret, oh, there's something related to the energy. It may be due to the aquifer volume. It may be due to the STOIB. So before making anything, we can stay finish, and we can go back again to the input. For example, that's just an example. And going back to the water influx, let's say that uh, for just an example, for example, and say done, and go back again for the history matching, see the analytical, and you can see that no major change. So it seems that like uh, the aquifer here doesn't has significant effect unless you make the second step, which is the regression. This is one of the most important tools. You will work on it, and you will have some kind of art. What I mean by art, you go to the regression, so you will see many parameters. Okay, you are here to choose. So I have a doubt about the oil in place, so I will make a regression on it. I have a doubt about aquifer permeability. Normally, there is no doubt about porosity, as you will get from your petrophysical friend. So no much doubt on porosity, no much doubt reservoir thickness. Encroachment angle, as I mentioned, we will assume it's like radial. So all of other parameters, oil in place, inner outer radius, reservoir radius, permeability, I don't know. So I may make some, let's try together. I will make some regression or calculation. So I will say it will take some time to make regression. As you can see, no more change, no significant change in the oil in place. However, he make uh, a significant change in the outer inner radius and the reservoir radius as well, with minimum change in the permeability. Okay, I can say that okay, best fit. Use these data. I say done. Okay, but however, still no much improvement. So in this case, we will need to go to the input data itself. We may input something wrong. We may have a doubt on the PVT and so on. So again, after you make your observation, PVT input, and your main input data, you will go direct to the history matching using your analytical method. Because in this analytical method, what is the objective? To have a match, to have this is the queue of the oil in place. So upon having a good matching of this data, it will give you a good estimation of the oil in place, and you begin to check if it's this oil in place equivalent or matching with the geologist, lower than, higher than, and you begin to think about the next system. Okay, so this is one of the most important steps to do. And again. Another method is the graphical method, but we will start initially with the analytical method, make our matching, and then go to the graphical method, and we called it a straight line method, which equivalent to no aquifer. If you can see deviations from this straight line, as you can see this data, so it means that there's some kind of aquifer. How can we make sure of this? We go again to the history matching and choose this dimensionless function plot. Okay, maybe something out of the range. I cannot see the data. Okay, so and this is for me also an indication of maybe there's something error in the data itself, in the input data in the PPT, that let you cannot see your data on the dimensionless time water plot, and also you cannot have a good match of the analytical method, because here it's like this is the purpose of this kind of sessions and the learning. So maybe I may use, let's say, a BBT from a case and input from another case, so it may not be matching together and so on. But in your data, in your provided data, you will see everything matching, and what you will do in case of history matching and so on, you will see it same. But okay, so this is mainly the matching. So again, you start with the analytical methods, make sure that you have a good match as much as you can, then go to the graphical to make sure about the aquifer and so on, and see your dimension list. It will give you just an insight about the aquifer. If you can see your data here in this line, all of your data here, so it means that this is like strong aquifer. If you can see any kind of deviations, so it is from weak to moderate aquifer, depending on this ratio or this line. Okay, and here is like a very good uh, plotting. You can make this all, and you can see all of your data, analytical, graphical, the dimensionless, and also you can see the source of your. As you can see, here there is no aquifer at all. You can see just the flow expansion and the pore volume compressibility. And normally it's not the way. For sure. For sure, there shall be any kind of aquifer, even if it's small aquifer. Okay. The final thing in this important list is the run simulation, and you can open this and begin to the calculation. Okay. In this simulation, it is considered the output of the MBAL. Let's say I will tell you what do I mean by the output. This is your history. Okay, this is your history. Look about what's included in the history. Just the cumulative oil, cumulative gas, cumulative water, these are the inputs you already entered in the MBAL. So what about other parameters I want to check on? I want to test like the rates, like the recovery factor, like the contact, and so on. This is a function of the simulation. You will have your simulation. Let's say this all, remove all, temperature pressure, simulation. Normally, for the simulation, we go and make a comparison between the pressure. As you can see here, also there is mismatch. So it suggests that we need to go and revise our data because it may be according to different parameters. Maybe the production data itself is not correct. Maybe the gas data, because we have uncertainty in the gas data, may be incorrect, and so on. So this it means that you don't have a matched model, so you cannot make a valid prediction. But again, let's come back to the main point, which is the difference between history and simulation. Simulation here, as you can see, we drop down many parameters. So from the simulation, about running the simulation and having good match, normally if you have a good match in the analytical, uh, if you have a good match here, if you started well in this way and you have a good match in the analytical and the graphical and so on, normally when you go to the simulation, you will have also a good match. Maybe you will see some differences as well. You will fine tune some parameters regarding to which affects the pressure. As you can see here, it is pressure with time, not pressure with cumulative and in the analytical matching. It's here it's here mainly about the pressure. So some parameters regarding the pressure, like the aquifer volume and so on, will fine tune the matching in case you have already a good matching for the analytical and the graphical. And when you have a good simulation, now you have a valid MBAL. So valid MBAL means that I can see a recovery, I can see rates, I can determine my saturation in the reservoir. Okay, if I want to use this kind of saturation, and I can have also some insights about my BPT with time. So many parameters I can detect from the simulation, which is one of the main objective of the MBAL. Okay. So till now, are you okay with the speed of the process, the logic and the coherence of coherence or some or in other words, I want to say that if is there anyone dropping from me or cannot coping, cannot see what I'm saying, has something in his mind, has some questions, we can have like 1 minute boost. So if you have any kind of questions, you can use the chat. I will see. If it's okay, we can go because I want to switch to the PPT part. It's because I believe it will be very helpful. So do you have anything in your mind right now? Hello? Can you hear me well? Okay, yeah. It's not like questions, but like say explanations, something like especially for people who are not till now clear, especially for people who are not familiar with the MBAL, because as I told you, we will try to do our best to provide you with different cases. We will ask you to make let's say more than four or five cases in MBAL, depleted cases, strong aquifer cases, different prediction cases, and so on. Before I want to show something also before switching to the presentation, which is, as you can see here, after you have a valid model, you can go to the prediction. I already have here some predictions. So, and if you have OFM, what's the difference? OFM is mainly for data visualization. Okay, the OFM, oil field manager, from its name, it's mainly for data visualization. You can visualize your production data, your pressure data, and making grouping categories as we talk. We are normally deal with categories. You can make categories with your company if you have different companies. Categories within the company for different projects. Categories with the reservoir. So you can divide data by reservoir, by platform, by separator complex, by field, by company, by operator, and so on. So this is the advantage of MBAL, so the OFM. And the relation here with MBAL is that I want to have the production pressure data of the whole tank. I don't need to have each individual well and make like a summation and calculation to have a tank production data. So what can help you with this? This is the OFM, unless I give you the data already for the tank. Uh, okay. What are the main parameters by which we can match perfectly or closely as possible? Let's say the question, yeah, in other words, let's say what are your uncertainties and what you are trying to do. So your uncertainties is the aquifer model. This is one of the main uncertainty. And sometimes the second point is that your gas readings, because normally you are suffering in gas readings. Um, and sometimes you have like anomalies in your production or pressure data but you will detect these anomalies if you have plenty of data, so you can easily detect the anomalies. The issue is that if you don't have enough data, so any anomaly cannot be detected, because right now it's not still an anomaly unless you have a trend so that you can decide it's an anomaly or not. Okay. What type of data can be imported into MBAL software? As I told you, you will in MBAL it's like a small simulation. So it also applies the integration concept. You need data from the geology, you need data from the petrophysicist, you need data from the BPT, and you need data from any of production softwares. Okay. Uh, This version, unfortunately, it's linked by, that's why I'm having two shares, because this virtual, I already purchased it for my own learning, self-learning, so it cannot be shared. But we have, I think, the previous version, which is already okay, and many people are working with it. It's IPM 11.5 version, so it will be okay. You can use it. We can, yeah, I think personally I can share it with you, yes, but with all of the teams, so that we can all work on it. Uh, question about code didn't make any effect. Uh, no, as I told you, it's maybe something related to inconsistency in data. For sure, if you activated a strong aquifer, you will see the effect on the pressure, okay, and you will see another important effect, will be on the oil base, because oil base and aquifer both are source of energy. So think about it. We have the total energy, sum of energy, say 0. So if you're gonna increase the energy from the aquifer, you're gonna decrease the energy from the oil in base. So that's why I'm saying the most sensitive one is the aquifer, because if you're gonna increase the aquifer volume, you're gonna negatively impact on the oil volume. If you're gonna increase the oil volume and so on. So for sure, the aquifer has a great impact. You will see on the pressure, you will see on the corresponding oil volume, and in the prediction, you will see in the nature of the movement of water, because for sure it will be different from case you don't have aquifer. So this is very nice discussion, and very good questions. Okay, let me choose the final thing in the software itself. I prefer to start with the software to be familiar with it, so that when I switch to the PPT and I'm saying QC of data and so on, you already imagined what is the value of this data in the software. Okay, so here I already have predictions. Okay, I have different cases of prediction. So this is one of the privilege of the MBAL as well, because now we have your history, which I mentioned is your input data. You have the simulation, you run the simulation, and it's okay, match it, and so on. So you cannot make a prediction unless you have a simulation, because prediction is already a simulation, but for time after your end time. So let's say now we are 2024, it's your end time. So the prediction is a simulation, but for time after 2024. So it's exactly like simulation. Okay. So now I can make cases in simulation and the prediction. I will predict that I have a well. and it will inject with 500 barrels of oil. Another case is 250. Another third case 100 injections. So if we're gonna remove all of this, and let's compare between, let's say, the pressure. So this is the pressure of the first case. The second case, this is the pressure. So can you see this? This is one of the advantages. The privilege has a quick. You don't need to have a simulation to answer your manager. So if this is like, and this, we called it a big term, FDP, field development plan. This is one of the items of the FDP, the field development plan. Simply, the development is that you're gonna answer some questions like this. What if I will inject with higher rate of water? What if moderate rate? What if low rate? So what will be the pressure regime? As you can see, here is like a slight increase in the pressure. There is a moderate or significant increase in the pressure. Here is like you can see a steep or high increase in the pressure. In this case, you may exceed the fracture pressure. So this case is not favorable because yes, it may theoretically give you higher oil, but it will make fractures for your reservoir. So for, let's see, remove all, and let's see uh, the cumulative oil, for example. Here is the cumulative oil from the simulation. We will suppose it's matched. So you shall go to the prediction and see what is your cumulative oil. It seems, as I told you, here also an indication that there is something not consistent. But as you can see here, started from the end point and began to completely go to years beyond. Uh, your rule will be to make something like this, to make some scenarios. Even we have different scenarios, maybe water injection, maybe gas injection, maybe telling you the compare between drilling 4 wells and other case drilling 3 wells, and see the impact on the pressure, the impact on the oil. And because you may say that yes, I can see incremental in oil, but the incremental in oil is not too much big to drill a new well with millions of dollars. So all of this helps you in your decision and your FTP plan. I can say question. Does the present aquifer have any impact on the reservoir? It's not like we don't deal like this. It's not negative or positive. Uh, but يعني in general, we say that having an aquifer means that you have a pressure support. So having a pressure support, especially with homogeneous reservoir, it means that you have a plateau of production. So generally, it's positive, not negative. Generally, it's positive, not negative. And the evidence of this is that if you don't have an aquifer and you have a depleted reservoir, after a while you are thinking about what? You are thinking about making secondary recovery by injecting water. So in general, it's not negative, it's positive, especially if you have a homogeneous reservoir. So it means that you will have a maximizing production. Okay, but maybe the negative sides or effects of having an aquifer or water in general is that you will have some scale problems in the well, some operation problems due to the water and incompatibility, due to the head on the formation and so on. But if you as long as you can deal with this kind of problems and you can produce a reservoir, so it's optimal, it's okay, it's very perfect. Okay, okay, so okay, can you see my screen?
Yes, it's loading, but we will see it.
Okay.
Yes, we can see it now.
Sure. Okay, so okay, just a moment for the then. Okay, again, sorry. That was for the exam. Okay, so coming to one of the most important part of this today's session, which is understanding and getting familiar with the MBAL. Because let me tell you something frankly that not all companies are using MBAL in a proper way, despite the fact that MBAL has many features or applications, as you will see. So simply the MBAL, as you know, uh, it's like just simply production volumes are removing from your reservoir, and it's like balance. That's why we call it material balance. Is that always what happening in your reservoir in terms of injection, expansion, and so on. At the end of the day, it shall be some kind of balance. So if you know what are you producing or production volumes removed, you can back calculation go and see what was initially in your reservoir. And for MBAL, we assume some assumptions that the reservoir pressure is constant for the reservoir each time, and the BPT, as we mentioned, is determined at different at initial case, and we are not. Yeah, for example, we have a field of 40 years, so we enter the BPT initially for this field. We don't account for any changes along the field in terms of water injection, gas injection, depletion of the reservoir, and so on. We just use the initial BPT. We assume, as you can see in the input, there is no tab for different porosity. It's only one value for each for porosity, for thickness. We don't, as you know, for a reservoir, for sure, it shall not have maybe have a formal thickness, and no, and normally we see that the reservoir has different thickness. You can see well with 40, with 50 feet, and another well behind or beside 100 feet, and so on. But in MBAL, we use just like if this kind of cases, you can see you can use like an average thickness, an average porosity, and so on. Okay. And as also as you can see in the MBAL, we use the oil, gas, water, any fluid injected or producing from your reservoir, we account for it. Okay. And one of the assumptions, it's not in the MBAL only, it is a simulation as well. We assume that the temperature is constant. This is one of the assumptions in the simulation, unless you are dealing with thermal EUR, heavy oil, and so on. For example, CMG. In CMG, we can model the temperature itself, but normally in our simulation, even 3D simulation or here zero MBAL simulation, we consider that the temperature is constant, which is not a fact, but it's minimal change, especially if there is no thermal projects. If you have thermal projects, you have to account for it for sure. Okay. Okay. This is one of the. I will give you like 30 seconds to look this. Can you imagine that normally you go for MBAL, it is just for oil in place, but as you can see, we can make too many applications using the MBAL. Okay. As you can see, one of the main well-known application is that estimating the oil in place, or let's say QC the oil in place. If you have already it, you can make a QC on it, or if you don't have it, you can make an estimation. I showed you the energy plot for the history matching. I showed you the analytical, graphical, the normalized, and the energy plot. So from this energy plot, which is the coloring green, blue, and so on, you can have like, let's not say determining, but have like an insights about is it gas cap, it is the aquifer, what is its combination, what is the source of energy of your reservoir, and regression in case of you are confirmed of your oil in place, you are confirmed of your you are assured of your production data, you are assured of your BBT data. So the only one remaining is the aquifer. So you can make some kind of regression, as I told you, it's art of science. Make some kind of regression to see that, oh, I can say now that I have a small pot aquifer. I can say that I have a moderate aquifer. I have a strong aquifer with this rough estimation of parameters. And here it's worth to mention that what is the importance of this modeling the aquifer? It will help you if you're gonna make a 3D modeling. So if you're gonna make a 3D modeling, you want to give the model some insights about the aquifer. So this may help you sometimes. Okay. You can see this the saturation. I told you that's why I prefer to start with a simulation with a software, because if I gonna start with a presentation, you will okay see all of this blah blah blah, but you cannot imagine what is it. But as I showed you in the MBAL for the simulation tab, I told you the history is just 4 or 3 lines, but for the simulation we have more than 20 lines, 20 lines. One of them is a saturation, the rate, saturation, and so on. So you can determine this saturation from the simulation in the MBAL itself. The relative permeability as well, because if you don't have a relative permeability, and I showed you that there is a tab for relative permeability. If you have it, you can input it. If you don't have it, I told you that it's not important in the history and simulation. It's important for the prediction. So we can use the interval of the history and simulation to make like an approximations for the relative permeability, and I can use it as well for the simulation, which is a very important thing. Estimating the average reservoir pressure is not normally in MBAL, but we can use it. We can get the pressure from different sources like the RFT, like the static pressure, like the pressure build up, and so on. But here he means that if you have all of your data in your hand, you have data about the aquifer, data about the production, data about the oil in place, so that you can back calculation go and estimate what was the initial pressure. Okay. The flow context is one of the objectives and applications to MBAL that we seldom use it. However, it's a very good indication that you can detect or predict the movement of the contact. Okay. Normally, people don't trust this results because it has some uncertainties, and you need to have more extra inputs from the geological point of view. The geology shall give you what we call a pore volume versus depth. It will give you like the shape of the structure in terms of percentage. So let's say the top of the structure is 0 until the contact. So it will give you like 0, 10%, 80%, and so on. Yeah, let's say that I'm sure not all of you may be familiar with what I'm saying regarding this point, but okay, you skip it now. But just have be aware of it, that we can use it for expected or tracking the oil water contact. And if we have a good results, or if we have a good match, it will save you a lot of money. Why? Because if you want to have to know the contact, you need to make well intervention. You need to run a hole with an expensive tool. You call it RMT or RCT, RMT or RST, to detect the contact. So it costs you money, and the causes you shut down with the oil. So if you have a very valid MBAL model, matched MBAL model, and you have a matching point of your contact tracking with any of the RCT in the history, it will save you a lot of money. Okay. Also, compartmentalization. I told you that if you have even the same name reservoir, let's say Balaim reservoir, but you can see it has different behaviors. So if you input the MBAL, the Balaim as just one Balaim, it will give you an insight of the compartmentalization. Why? You will see like mismatch in the data, as maybe our model, which I was showing, maybe have some this kind of heterogeneity, because I'm using just one thing. Maybe if I go back and revise the data, I see that it has different pressure production performance, so it has anomalies. Let's imagine it has 2 clouds, so I shall give the MBAL 2 tanks, and that's why maybe you cannot have a good match. So this is a very good point. If you trying all of you what's in your hand to make a matching, changing the data, QC the data, make your art of regression, and at the end of the day you cannot have a good match, it may be inside that you have multiple tanks, you have 2 tanks, you have 3 tanks, you have compartment. Compartment means that it's not connected together. So different behavior in different region. Okay. And for sure, the last one is the prediction scenarios, as I showed you how we can predict different scenarios of water injection and so on. Okay. So this is very important slide. So if you have any questions regarding this point of any clarification, because I expect that even people who are working with MBAL, I don't expect that they all know that MBAL has all of this application. Maybe mainly the oil in place and the prediction scenarios, but I'm not sure that they can use it for saturations, movement of contact, so on. So if you have any questions, clarifications, feel free. If not, I will move on. So this is like a simple clarification. I will not take too much. Is that Mr. Matching, you make an input, and in prediction, you're trying to estimating what's required. So let's go to a very important point, which is your input data. I think I had a question. Some asked me. So you can see, I can share this slide with you as well. No worry. You can see in this slide there is like all of data you need to have to start your MBAL. So you need to know about your fluid model, it's single, as I mentioned, or different reservoirs, your BBT, your estimation of oil in place, compressibility, and so on, if consolidated contacts, relative permeability for production, the pressure history. I think now it's super easy because already I think you already saw it on the MBAL itself. Okay. So please pay attention for this upcoming slide. This is very important. This is what I'm saying. Okay, this is what I'm saying. This is your data. Okay, and you are making your matching. So one will come and ask engineer, okay, I have matched all of these historical data, but what about these 2 points? So think about it. What about these points? For sure, it will be unlogic data. It will be anomaly data. This is what I'm saying by the term of anomaly or illogic data. That's so it means maybe if you come back to your to the process or the program for acquiring this data, you will meet some failure. You will see some failure. For example, the pressure. This is called the static pressure point. Okay, this point or this point or this point or this point. We call a static pressure. This is a recording of pressure using a gauge in the hole and the recording of pressure. So to record a pressure in the well, you have some, let's say, some steps. Okay, one of them is to have an efficient or sufficient shut-in time before you're recording your static pressure. So in these 2 points, maybe you don't have enough time. You didn't have enough shut-in time to have a representing static pressure. So it's called failure. So you will neglect these points in the MBAL. So and continue your matching no way. Okay. Another point is that your gas. I told you that we normally have much uncertainty in the gas measurements. We normally care with oil measurements, somehow with water measurements for determining the water cut and so on. But for gas, you will have some uncertainty. So one of the QC is that we know that if we have a pressure of the reservoir above the bubble point pressure, so that we have a constant RS, which is, for example, 800, 700, 600. So, and you have a constant RS and you have an oil rate, so you can easily determine your gas volume, your gas rate, right? Right. So if you can see that the gas reported or measured is different from the gas rate calculated from the BBT, so for sure you have some uncertainties and you need to trying to correcting this data because gas means energy. So producing more gas, putting more gas in the reservoir, changing this type of amount of gas means changing the energy like the water exactly. Increasing injection water, decreasing injection water, it will have an effect on the energy, which I mean the pressure. Okay. QC, quality check or quality control. Yes, right. Quality check or quality control. Okay. Hopefully, everything is okay. Okay, so the upcoming 2 slides, I think it will be super easy because we already discussed it on the software itself as the history matching steps. As I told you, we start initially, firstly, analytical method, and secondly, we go for the graphical method. Simply here is like, as I told you, the analytical method, it's like pressure history, trying to history match the pressure, and you have some parameter to make a regression until you have a satisfied. You will be, it's not exact matching with the data. I don't think you will reach this level, especially if you are dealing with the real data. Maybe in the textbook data, it's already made backward, it's made to match this. But for real data, it's forward. You have your data and you make your model, so you are subjected to have some anomalies and uncertainties. Okay, as you can see, two of the main parameters coming from this analytical matching is the oil in place. This one is the oil in place, and the volume, the aquifer of volume. Please don't neglect the volume, the volume aquifer, calculated aquifer volume. Take this number, keep it, keep it for later. And if you have a simulation, you may use this number. And you in simulation, you have many sophisticated tools to make quality checks. So it may give you like an insight. So please don't neglect this number because you already make some assumptions, some regressions, and you already have some insights about your aquifer as well as your oil reservoir for sure. So these two numbers, oil in place, okay, and the aquifer calculated aquifer volume. These are of the two main parameters coming from the analytical method. Okay, I don't want to take too much time on the graphical method. It's mainly uh, it's mainly the equation of the material balance, including all parameters of expansion, water injection, water influx, and so on, and all of the ways and techniques for this. It's all about the way the aquifer behaves. What does I mean by the way? I mean that it's steady state, it's unsteady state, small aquifer, relative volume. So all of this like mathematical equations, okay, depending on the select aquifer, and all the difference between all of them is mainly for, as I told you, as you can see here is from the MBAL, and here is the equivalent equation. You can see this all rearranging the equation to account for, as you can see, Campbell plots accounts for no aquifer. So you can start with it, and after that you will go and say that it's okay. We have now aquifer. So this aquifer for Havlina it will be unsteady, which is for big aquifers and so on. So it's some kind of try and error, and also depending on your understanding, but it's more about try and error to check this aquifer Campbell without aquifer. So it doesn't work. So go with Campbell with aquifer and so on. Okay, as you can see, something like this. Like this is the Campbell. As you can coming back to the equation. This is the simplest one. Okay, simplest one. We normally start with this Campbell, no aquifer, and see our depth. If it's straight line, as I told you, it is a depletion. So actually, yes, no aquifer. If you can see any deviation or trending, so it will be aquifer, whether it's weak aquifer, moderate aquifer, strong aquifer, as you can see. So this is like your first step in the graphical. After that's why I told you we start with the analytical matching. Start with analytical matching, make our science and art, and make a validation. So we now go to the graphical. The graphical accounts for different, mainly the water injection, water influx. So it's all about mathematics. And as I told you, the aquifer, we don't have a solid hand on aquifer. We have uncertainty with aquifer. So as a result, you will have also uncertainty in the graphical matching, and that's why we depend mainly on the analytical matching. But it's worth to mention that starting with Campbell plot for no aquifer, and you can see your data. If it fits the horizontal line, so it's okay, it's a deviation. If any deviation, so you have an aquifer. Okay. Okay. And as I told you, if you have any discrepancy, you have to challenge back your data and or your BPT, something as I told you, for example, on the model I showed you, I told you, yes, I have to go back and see, or starting a new model, because I may collected BPT data, which is not the BPT of the reservoir, or I collected production data, which is not related to the BPT of the reservoir. So no harming, no matching, which may result in something like this. Okay. Okay. I think you are about to finalize. Okay, the energy bot. I should use the energy bot. It's a very good coloring chart, graphical representation of. You can just have a quick view of it. You can see, yeah, oh, I have most of my energy from water and some from bore volume expansion or compressibility and fluid expansion. In other cases, you don't have water and you have gas. Maybe you have segregation, in case of high deviated reservoirs and so on. So it's like it's not a quantitative, so you cannot take it and make like percentage. Normally, it's like a qualitative to see that, oh, okay, for this I can see that most of my energy is from the aquifer, so that I can expect that the pressure is sustained. I can expect that I will cut water in the prediction scenarios and so on. Okay. The final thing in this point is that this plot, which I was not able to see you, how can you use it as a real data? As you can see, this is the dimensionless aquifer type curve. You can see that matching your data, you will see your data something like this. You will see data here or there. So if it's going matching with some line of this, it is corresponding to an indication of the volume of aquifer, strong aquifer or moderate aquifer, and so on. The more your data is deviated, it means that weak aquifer. The more your data is going straight up with this type curve line, it means that a strong aquifer. Also, it's something qualitative along with the package of the history matching. Okay, is it okay right now? Okay, so after the history matching, I told you that we will go and run the simulation. If you can remember, I told you when we run the simulation, we see that there is some mismatching between the pressure, and here is like something like this. As you can see, the history and simulation. So you can compare between two parameters. Mainly, we normally go with two parameters. For me, I prefer to start with the pressure. As you can see, if I can see a mismatch, so I'm sure that all of the model is not matched, so I need to work on it more again. But normally, if it's the pressure, you can see the pressure is okay. So go for the second parameter, which is the cumulative. You shall have something like this. Yeah, I can see that it's identical. It's not like matched, it's identical. The history, the history is typically matched with the simulation. The history is these bullets, triangles, and so on, or these squares. The simulation is the line. So you can see the line is crossing all of the bullets, and here is the line is crossing. It means that this identical. Maybe you cannot see this in the real life, but you are trying to approaching this kind of matching. Okay. If you cannot see this kind of matching, so again, you will debate your data first. If not, so maybe something different in the geological model. It's not just this kind of reservoir in terms of permeability, porosity, oil in place, and so on. Okay. The final thing regarding the prediction, I told you that what we are doing in the MBAL is considering under the umbrella of FDP. You know, the FDP is a big term, field development plan. Field development plan means that you are trying to maximizing your production, adding more reserve by studying different options and make comparison and see what's valuable, what's commercial, and so on. One of this is run as I showed you in the MBAL, different cases of water injection. Sometimes is to design drilling schedule and see the effect. Voidage, if you have a water injection and you want to determine the optimum injection strategy, and if you have a gas and you want to make a gas injection and so on. Also, but we will not work on this item in our internship, which is the economic visibility, because we need too much figures about the prices of everything like gas lift, ESP, and the price of oil and so on. And as you can see, for sure, we can determine the production profile for our well and parameters and so on. Okay. Okay. So, Zapka, I think I'm about to finalize. I know that I'm consuming time, uh, but take this in your account for some general information about MBAL. One of them is that you cannot, when you are working with MBAL, you may not find a BVT for your reservoir. So at that time, you will need to go and check for equation of state. So I can pause and see questions. Please repeat which.
I think
Uh,
she means the dimensionless slide.
what?
The dimensionless slide.
The dimension slide?
Yeah,
Yeah,
I
okay.
think
So,
so.
okay, it's as I mentioned, it's like a qualitative to according with your previous plots to see some insights about your aquifer. It's mainly for the aquifer. Mainly this plot is for the aquifer. So, uh, let's say I'm not sure if I can. I will use the pen. Okay, it's okay. Can you see my pen? So if your data is here, something like this, can you see my pen?
Yes, we can see it.
Okay, this is means that strong action. Okay. In case you can see your data is deflecting, so something like let's say something like this. As these two colors, red and the blue. This red and the blue colors, these ones, it means that it's moderate aquifer. Maybe here is moderate, and here is the small aquifer, something like this. As you go here in this direction, okay, make like a straight line, it's a strong aquifer. So it's something qualitative to check your aquifer. And as I told you, the main point about having information about the aquifer is to use it later if you have any kind of simulation. But for time being, if you don't have any kind of simulation, for sure, we will not go and drill in the aquifer. So we don't use any kind of this information. But if you have a simulation and you will suffering from history matching and so on, and again the aquifer will come again and tell you I have uncertainty. So you can gap the uncertainty if you have an MBAL model like this one. Got it right now? Okay. What's else? Means you don't understand the problem. Please repeat the slide. Uh, will we be using Inbetsu as well to complete our hours? Yes, for sure. Yes, I'm saying yes. I'm just here to give you this introduction and this workflow on the Inbal. Until you have the data in your hand, you will have the data and the requirements, what to do from the data, and you will start working on this data. Okay. Okay. So again, for regarding the general data, it's something to keep in your minds, something not important, but to know that you may not see the BVT for some specific reservoirs, and at the time you need to have like an equation of a state. As I told you, imbalance the zero dimension, so he assumed the averaging of each data. He assumed a constant for sure the gas is not constant, but he assumed that's constant. Um, One of the main important things is to make sure that you have accurate production data, because the spirit, or let's say the driver or the engine of the MBAL, is your input production and pressure data, and also the pressure as well. So your initial pressure trend, production data are all of the main things to consider when you are going to make your MBAL. Okay. So MBAL for sure cannot be used in all cases. So these are some types of favorite cases in MBAL. If you have like we tell it, we say it, sandy cake reservoirs, thick reservoir, high permeability, low viscosity, and the pressure is easily obtained and so on. MBAL, we don't prefer to use MBAL in heterogeneous reservoir, because as I mentioned, MBAL will, if you're gonna use it with heterogeneous, so MBAL will tell you you have many compartments. So many compartments means that you have a scattered data, and it means that you cannot have a good match, and it means that you will have much work to trying to have a match, and at the end of the day, you will not be able to have a match. So you will not have a valid model, so you cannot make anything. Okay, that's the problem. Uh, Mainly if you don't have water because of the uncertainty, nor gas for sure, so that you have like you can see like depletion of the reservoir along with the production data, so that you can estimate. If you have a strong aquifer, normally we don't use MBAL, unless for some cases like uh, trying to match the contact or something like this. But normally we don't use MBAL for just cases. Maybe we use it for prediction of the water itself. So in this case, I will not focus on the oil, but I will predict the water performance. And if I have like sustained pressure, which means I have a sustained fluid, so predicting the performance of water will, in result, give me a prediction about the oil performance. This is some of the cases we can use it in homogeneous in uh, in strong aquifer reservoirs. Okay. So material balance, as I told you, it will not give you any geometrical description of the reservoir. It will not give you any location of unswept oil. It will not give you any target for infill wells. It's all about mathematics. It will tell you instead of unswept oil, it will tell you there is oil or not, there is saturation or not. It will not give you target, but will you to drill wells or not, the impact of drilling wells or not. It will not for sure give you any direction of your data. And finally, remember this. Uh, if you're gonna work in on-bal specifically or any simulation, first of all, you're gonna collect data, and I think it will be our role if you use the data. Your role is make your QC, make your plottings, seeing your. So for example, one I still can remember a story that one sent me a cumulative data that is going down. So how come cumulative data? Even if you have anomaly in the data, you are cumulating, you are summing, you are. So in case of going down, it means that you are entering the production in minus. That's why commuter is going down. So commuter shall be going up always. Okay. Check your production data and your gas data and source. Then you begin your history matching using analytical, graphical, and finally make your simulation validation and begin to make your prediction slide and so on. So now I have come to an end for this session today. I'm really thankful for your competency and your enthusiasm. I'm all ears. If you have any questions, again, I prefer to give you the main trick points or the main understanding of the software itself and how you're gonna use it. And to give you a hint, as we started the session by the workflow and what you shall input, what you shall look at. And trust me, you need to make it yourself uh, based on the data provided with your team. And this is also another objective of the asset team is that you can helping each others. It's not one reservoir, three reservoirs, engineers, three PT engineers, two drilling. So you can have online meeting together and so on, and begin to discuss data and how to make it and so on. Okay. So thank you again. If you have any questions, please let me know. I will be again with you for the well test. Maybe think Adel Saturday or Saturday, yeah.
Yes,
Saturday.
we just need to confirm the timing and we will announce. So thank you,
Okay.
Engineer Karim, for this wonderful session. Let's have a 3 minutes break to fill the feedback form that I will send in the chat box right now.
اوبا فيدباك ليه بقى ليه المفاجآت دي؟ Then Bell will be yes yes thank you so much. Okay, thank you Selma. Then Bell being used for commercial or industry use in big, yes for sure, yes for sure, yes I'm saying yes for sure. We use the whole package of the IPM Prosper, despite the fact that PipeSim is not a real package, but normally we use it with Prosper. And the combining, you shall be familiar with the term IAM, integration asset modeling, which is coupling the gap MBAL and Prosper. For sure, we use MBAL, but as I told you, due to some uncertainties and not familiarizing with the MBAL, we don't use it effectively. Let's say in this way. What is the benefit of using MBAL potential for production? This is another module, Shihab. What type of analysis can be using the machine plans module in MBAL between? I'm sorry, I cannot certain. What do you mean, but what type of analysis? Yeah, for production allocation, actually, I didn't use it because we have our allocation software in the company, and it's something trying to find the gap between the actual test and we call it the allocated, something advanced but it's not in the MBAL. It's one of the tools that I told you, like the 1D, like the multi-layer and so on, and the production allocation. It's different, yeah. But for allocation, it's normal. I told you trying to matching the actual test data. What I mean by matching the actual test data, let's imagine that we have a well produced for 3 years. So what frequently we have tested for this well? Normally, it's not daily, not monthly. Maybe you have just one test by 6 months, each 6 months. So you have along the lifetime of the well, the six points. So how can you report the production of this well if you have only 6 minutes, 6 points? So we introduce a type of allocation of the production allocation. So how to match between this allocation and the actual test? If it's only for one well, so the allocation will be likely the test. But consider this well is in the network of more than 400 wells like us in Gapco. So it's nightmare. So it will be something trying to run the backward calculations to have like sort of, so introducing MBAL may help us. iPhone is different than HISIS, totally different. HISIS is يعني downstream software, and mainly you can insert the surface facilities like separator, heaters, together, and so on. And you can predict the type of flow assurance, like somehow like Olega, but not exactly like Olega. And you can determine the hydrates formation, any problems with the horizontal line, and so on. So it's totally different from Hive. Okay. Okay. Shahab, thank you, Shahab. Any more questions? Are you ready? Are you ready for the MBAL tasks? Inshallah. Thank you, Muhammad. Salma, thank you, Salma. Uh, mm, thank you, Tariq. Thank you, Ahmed. Maddu. Thank you, Hamza. Thank you, Shahab. Thank you again. Okay.
Okay, so I think this is all for today. Thank you again, Engineer Karim, for this wonderful session. And thank you all OPA interns for attending today, and see you tomorrow, inshallah.